Good morning, everybody. I am Dr. S.S. Naidu, Assistant Professor in Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, we are going to discuss a very important topic in probability and statistics. It is mean, variance, and mode of binomial distribution. Previously, we have discussed about binomial distribution. This binomial distribution is a distribution which holds for discrete random variable. Now, in that discrete random variable concept, we learned so much about a binomial distribution. Today, we are going to discuss about mean, variance, and mode of binomial distribution. Mean is nothing but estimation. It gives central value. That's why previously we have some idea about mean, median, and mode. They are central tendencies. So the central tendencies are mean, median, and mode. Like that, standard deviation, variance, all these quartile deviation, all these things comes under measures of dispersion. So today we are going to discuss about how to find mean, variance, and mode of binomial distribution and what are their properties. All these things we will discuss elaborately. First of all, let us see what is mean and variance of binomial distribution. The binomial distribution with the parameters number of trials n and probability of success p is the discrete probability distribution of the number of successes in a sequence of n independent experiments, each asking a yes or no question, and each with its own Boolean valued outcome success of failure. Here, what is Boolean valued outcome? We know the entire Boolean algebra we discuss with two numbers. They are 0 and 1. Here, these values are called Boolean valued outcomes. So here for Boolean, we will give for success and failure, we assign these two numbers for them. If it is failure, we assign it 0 for it. If it is success, we assign it 1. So we assign 1 for success and we assign 0 for failure. That's why this success or failure we denote with Boolean valued outcomes 0, 1. These Boolean valued outcomes means 0 and 1. Mean and variance. These are the properties of binomial distribution. The concept of mean and variance is also seen in standard deviation also. Binomial distribution is a topic of statistics. Mean deviation is also a useful topic of probability. So here if we find standard deviation, then if we take square of that standard deviation, it gives us our variance. So variance is equal to plus or minus square root of standard deviation is equal to plus or minus square root of variance. Now let us define mean. Mean is the expected value of binomial distribution. It is calculated by multiplying the number of trials n by the probability of successes p, that is n into p. So np, that np value gives us our mean or expected value. Now how to find variance? variance is a measure of dispersion, as we discussed earlier, that takes into account the spread of all data points in a data set. The variance is the mean squared difference between each data. So variance is the mean squared difference between each data point and the center of the distribution measured by the mean. So what is the mean and variance of a Bernoulli binomial distribution? Bernoulli, when do we say it is Bernoulli binomial distribution? When number of trials becomes 1, n is equal to 1. Bernoulli distribution is a discrete probability distribution for a Bernoulli trial. Bernoulli trial means n is equal to 1. It is a random experiment that has only 2 outcomes, usually either a success or a failure. For example, the probability of getting a head, that is a success while flipping a coin, is 0.5. The probability of failure is 1 minus p. We denote it as some q. 1 minus the probability of success, which is also equal to 0.5 for a coin toss. It is a special case of the binomial distribution for n is equal to 1. Now Bernoulli trial. In other words, it is a binomial distribution with a single trial. Example, single coin toss. The expected value for a random variable x for a Bernoulli distribution is expectation of x is equal to p. For example, because y, n is equal to 1, so y and p value will give you mean. So 1 into p is equal to p. That's why for Bernoulli distribution, expectation is equal to p, probability success. For example, if probability is equal to 0.4, probability success is 0.4, then expectation mean will become 1 into 0.4 is 0.4. So the variance of a Bernoulli random variable is variance of x is equal to p into 1 minus p, same concept. N becomes 1, so p into 1 minus p will become variance of a Bernoulli random variable. Now let us see derivation of mean and variance of Bernoulli distribution. Now let us see the derivation of how the formula of the mean and variance are derived. Let us see, mean is equal to mean and variance of binomial distribution. Let us prove like this. Now let us take p of x is equal to ncx p to the power x into 1 minus p to the power n minus x. It is our basic formula, general term to formula. Now expectation e of x is equal to, it is nothing but our mean, is equal to sigma n is sigma x is equal to 0 to n x into ncx into p to the power x into 1 minus p to the power n minus x. So it becomes sigma x is equal to 0 to n factorial by x factorial into n minus x factorial into p to the power x into 1 minus p to the power n minus x. Now this becomes equal to sigma x is equal to 1 to n factorial by n minus x factorial into x minus 1 factorial, y we are taking from 1, into p to the power x into 1 minus p to the power n minus x. Now our estimation e of x will become sigma x is equal to 1 to n. Yeah, we are arranging, we are adjusting the terms. That n factorial we wrote it as n into n minus 1 factorial. By denominator n minus x into x minus 1 factorial into p to the power or x minus 1 p to the power x, we wrote it as p into p to the power x minus 1 into 1 minus p to the power n minus x. So you take n common, p common, n into p into sigma x is equal to 1 to n minus 1 factorial by n minus x into n minus x factorial into x minus 1 factorial into p to the power x minus 1 into 1 minus p to the power n minus x. That is equal to n into p into sigma x is equal to 1 to n minus 1 factorial by denominator we are adjusting n minus 1 minus x minus 1 factorial into x minus 1 factorial. N minus x factorial we adjusted as n minus 1 minus of x minus 1 and remaining everything same. P to the power x minus 1 into 1 minus p to the power n minus x. So it will become n into p into sigma x is equal to 1 to n x into n minus 1 c x minus 1 into p to the power x minus 1 into 1 minus p to the power n minus x. We put 1 minus p is equal to q. Then it abridges to np into sigma x is equal to 1 to n into x into n minus 1 c x minus 1 p to the power x minus 1 into q to the power n minus x. Then elaborate, spread it, np into that sigma we are splitting n minus 1, we are using formula n minus 1 c naught q to the power n minus 1 plus n minus 1 c 1 p into q to the power n minus 2 plus n minus 1 c 2 p square into q to the power n minus 3 plus etc. n minus 1 c n minus 1 p to the power n minus 1, just expansion. It becomes n minus 1 c naught q to the power n minus 1 plus n minus 1 c1 into p into q to the power n minus 2 plus n minus 1 c2 into p square into q to the power n minus 3 plus etc. n minus 1 c n minus 1 p to the power n minus 1. So the binomial expansion of p plus q to the power n, it comes as it is nothing but binomial expansion of p plus q to the power n minus 1. So expectation of x is equal to n into p plus q to the power n minus 1. But we know that p plus q is equal to 1. So expectation of x is equal to n p into 1 to the power n minus 1. It is nothing but n into p. This is the mean of the binomial distribution. So a mean or expected value of binomial distribution is equal to n into p. Mean and variance of negative binomial distribution. The negative binomial distribution is a discrete probability distribution that models the number of successes in a sequence of independent and identically distributed Bernoulli trials before a specified non-random number of failures denoted or occurs. For example, we can define rolling a 6 on a dice as a failure and rolling any other number as a success and ask how many successful rolls will occur before we see the third failure r is equal to 3. In such a case, the probability distribution of the number of non-successes that appears will be a negative binomial distribution. We could similarly use the negative binomial distribution to model the number of days a certain machine works before it breaks down. Means R is equal to 1. So in a sequence of independent Bernoulli trials, let the random variable x denote the trial at which the rth success occurs, where r is a fixed integer. Then probability of x is equal to x such that r comma p are existing is equal to x minus 1 to x minus 1 c r minus 1 combination p to the power r into 1 minus p to the power x minus r, where x is equal to r plus 1, etc. Now let us see properties of mean and variance of binomial distribution. The properties of mean and variance of binomial distribution, among them first one is, since p and q are numerically less than or equal to 1, it is clear npq is less than n into p. Since why? Because the product of p and q is definitely less than 1. So n into less than 1 is definitely n into p. So q is less than 1. So np into less than 1 less than np. So that's why npq is less than np. Next, second property. The variance of a binomial variable is always less than its mean. By seeing this formula, we will come to know. The variance of a binomial variable is always less than its mean. The variance of a binomial variable x attains its maximum value at p is equal to q is equal to 0.5, and this maximum value is n by 4. So the variance of binomial variable x attains its maximum value at p is equal to q is equal to 0.5, and this maximum value is n by 4. So the variance of binomial variable x attains its maximum value at p is equal to q is equal to 0.5, and this maximum value is n by 4. So the variance of a distribution measures how spread out the data is. Related is the standard deviation, the square root of the variance, useful due to being in the same units as the data. Standard deviation, we denote it as sigma. Now let us see square of standard deviation means square of sigma. It is nothing but variance. So variance is equal to plus or minus square root of standard deviation. So the mean or expected value of a distribution gives useful information about what average one would expect from a large number of repeated trials. Now let us see applications of mean and variance of binomial distribution. The manufacturing company uses binomial distribution to detect defective goods or items. In a clinical trial, binomial trial is used to detect the effectiveness of the drug. Moreover, the binomial trial is used in various fields such as market research. In a manufacturing context, the number of faculty items in a batch of products might follow a binomial distribution if the probability of failures is constant. In statistics, for a moderately skewed distribution, there exists a relation between mean, median, and mode. This is called empirical relationship, which is defined as mode is equal to the difference between 3 times the median and 2 times the mean. So, mode is equal to empirical relation 3 times median minus 2 times mean. This is called empirical relationship. Mode is equal to 3 times median minus 2 times mean. This is called empirical relationship. This relation has been discussed in detail. To recall, mean is the average of the data set which is calculated by adding all the data values together and dividing it by the total number of data sets. Median is the middle value among the observed set of values and is calculated by arranging the values in ascending order or in descending order and then choosing the middle value. Mode is the number from a data set which has the highest frequency. It comes more number of times and is calculated by counting the number of times each data value occurs. Mean is the average of the data set which is calculated by adding all the data values together and dividing it by the total number of data sets. Now let us see mean, median, mode relation with frequency distribution. Frequency distribution curve with symmetrical frequency curves. If a frequency distribution graph has a symmetrical frequency curve, then mean, median, and mode will be equal like this. Here in this situation, if a frequency distribution graph has a symmetrical frequency curve, then automatically mean will be equal to median, median will be equal to mode. Then that graph comes like this. Now, for positively skewed frequency distribution. In case of positively skewed frequency distribution, the mean is always greater than median and the median is always greater than the mode. Here on the x-axis we are taking probability showed frequency distribution and then this graph is coming as some bell-shaped graph. In that, first one shows mode, second one median, third one mean. They are coming like this. For negatively skewed frequency distribution, then the graph comes like this. In case of a negatively skewed frequency distribution, the mean is always lesser than median and the median is always lesser than the mode. That we showed here like this. Here mode is greater, after that median, after that mean. It comes in descending order. Here mean is less than median, less than mode. That is the case here. Now let us see properties of binomial distribution. The properties of the binomial distribution we can discuss like this. There are two possible outcomes, true or false, success or failure, yes or no. There is n number of independent trials or fixed number of n times repeated trials. The probability of success or failure remains the same for each trial. Only the number of success is calculated out of n independent trials. Every trial is an independent trial, which means the outcome of one trial does not affect the outcome of another trial. Now, these distributions have two modes. A bimodal distribution has two modes. In other words, the outcome of two processes with different distributions are shown together in one set of data. It occurs. It is also known as double peaked distribution. For example, data distribution of two production ship data in a manufacturing plant comes under double peaked distribution. So, we are discussing mean, variance and mode of binomial distribution, and let us once again recapitulation. Let us see. As a part of under recapitulation of this topic, we are all discussing about different properties, and we defined mean, variance and mode, and we have discussed about empirical formula. Means it gives the relation between mean, median and mode. Empirical relationship, which is defined as mode is equal to the difference between 3 times the median and 2 times the mean. So mode is equal to 3 times median minus 2 times mean. This is called empirical relationship. Like that, we can discuss different cases in mean, median and mode, which are mean, median, mode come under central tendencies, and variance, standard deviation, quartile deviation, all these come under measures of dispersion. Like that, for a binomial distribution, we can define mean, variance and mode elaborately. Thank you. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.